Students, welcome to Methodology classes. In class 10th mathematics series, today we are going to discuss the concepts related to exercise 1.2 and the questions from the NCERT book exercise 1.2. So I will get out of your sight and let us totally focus on the maths. So before starting the concepts related to exercise 1.2, let us try to find out what the numbers are made up of. To know what a thing is made up of, we have to break them down into their smallest parts. So we will do the same thing with the numbers also. So to understand that, let us take a number 140 and try to break it down into the smallest particles in which it can be broken down. So this is an even number, so if we divide it by 2, so it will go 70 times. Now 70 is again an even number, so we can break it down again. So it will be 35 times. Now 35 has the unit digit 5, so we can divide it by 5. So 2 has come 2 times, so we can write it 2 square times. If I divide it by 5, so 5 times 7. Now 5 and 7 cannot be broken down more, and 2 also cannot be broken down more. So these are the smallest particles from which 140 has been made up of. In a similar way, to make our concept a little bit more clear, let us take another number 156. So 156 is again an even number. So divided by 2, so it will go 78 times. Now 78 is again a even number, we can divide it by 2 once more, so it will be 39 times. Now 2 has come 2 times, so 2 square, and 3 plus 9, 12, and 12 comes in the table of 3, so we can divide it by 3, so it will be 3 times 13. Now 3 and 13 cannot be broken down more, so we can see that 156 has 2 times 2's, and 1 3 and 1 30. So these are the smallest particles from which 156 is made up of. We cannot break it more. So if we analyze what are these numbers 2, 5 and 7. So to analyze that, let us think about the factors of 2. So 2 has only 2 factors, 1 and 2. 5 has only 2 factors, 1 and 5. 7 has only 2 factors, 1 and 7. 13 has only 2 factors, 1 and 13, and 3 has only 2 factors, 1 and 3. So these are special type of numbers which has only 2 factors. To be more specific, we can say that they have only 2 positive factors. So these are very important in mathematics. Such numbers has been given the name prime numbers. Prime numbers. We all have been studying about the prime numbers from our childhood, and how we define prime numbers. A prime number is a positive integer which has only 2 positive factors. So students, we have to be very cautious when we study the definition of anything, any concept, because if we don't understand the definition properly, then we will make mistakes. And in the definition of anything, every word has its own importance. So we have to focus on each and every word. So how we define prime numbers? A prime number is a positive integer. So first of all, it should be a positive integer. First of all, it should be a positive integer. And what are positive integers? We understand positive integers are 1, 2, 3, 4, 5 and like this. So it should be a positive integer, means it should be an integer out of these and which has only 2 positive factors. So which has only 2 positive factors. And to be more specific, what are those 2 positive factors? Because every number is divisible by 1 and itself, so we can also say a prime number is a positive integer which is divisible by 1 and itself only. So every number will have 2 positive factors, 1 and itself. So a prime number is a positive integer which has only two positive factors. To take an example, the smallest prime number is 2. 2 is the smallest prime number. 2 is the smallest prime number, and it is very important prime number because it is a single prime number which is even. All other prime numbers are odd, because if you take any other even number, so that will be divisible by 1 and itself, and in addition to that, that will be divisible by 2 also. So the smallest prime number and only even prime number is 2, all other prime numbers are odd. So I hope this definition would be clear. A prime number is a positive integer which has only 2 positive factors. In exercise 1.2, all the questions are based on fundamental theorem of arithmetic, and the base of fundamental theorem of arithmetic is prime numbers. That's why we discussed prime number first. And every number, every integer, positive integer, is made up of prime numbers only. So now let us move to the fundamental theorem of arithmetic. So what does fundamental theorem of arithmetic states? It states that every composite number. What is a composite number? Composite number is a number having more than 2 factors. More than 2 factors. A number having more than 2 factors is known as a composite number. So, fundamental theorem of arithmetic states that every composite number can be expressed as a product of primes. Can be expressed as a product of primes, and this factorization is unique, means it is unique apart from the order in which the prime factor occurs. Apart from the order in which the prime factors occurs. So every composite number can be expressed as a product of primes. As we saw above, we expressed 140 as 2 square times 5 times 7 and 156 as 2 square times 3 times 13. So every composite number can be expressed as a product of primes, and this factorization is unique apart from the order in which the prime numbers occur. Means someone can write this as 7 into 5 into 2 square. Another person can write it as 5 into 7 into 2 square. So the orders can be different, but the composition will remain same. Every factorization will contain 2 times 2, 1 times 5 and 1 times 7. Order can be different, but the composition will remain same. Similarly, this can also, someone else can get this as 13 into 3 into 2 square. Or another person can divide it by 3 first, then 13, then 2 square. So the orders are different, but the composition will remain same. So this is what all fundamental theorem of arithmetic is about. Now, using fundamental theorem of arithmetic, we can find out SCF of two numbers. And how we find out? Product of the smallest power of each prime factor in the number. So if there are two numbers and we have to find out the SCF. What is SCF? The highest number which divides the given numbers. To find out the SCF, we will do the prime factorization of the given numbers, and we will take the smallest power of each common prime factor. So we have to focus on these words. Smallest power of each common prime factor. So common prime factor means the prime factor which occurs in all of the given numbers, and out of all those common numbers, we have to take the smallest power of each common prime factor in the given numbers. Similarly, by prime factorization, we can find out the LCM of the given numbers also. And how we find out the LCM of given numbers? It is given by product of the greatest power of each prime factor. Product of the greatest power of each prime factor. So in the SCF, we were taking the smallest power of each common prime factor, but in the LCM, we have to take the greatest power of each prime factor. So in case of LCM, we don't have to see whether that prime factor is present in all the numbers or not. We have to take the greatest power of each prime factor, even that prime factor is present in only one of the given numbers. So these are the, I hope you would have understood the difference between the SCF and the LCM. And LCM is the least common multiple, means it is a multiple which comes in the table of each of the given number, and it is smallest among all the multiples. And SCF is the greatest among all the factors. So SCF will always be less than or equal to the smallest of the given numbers. So SCF will always be less than or equal to the smallest of the given numbers, and else if we think similarly, LCM will be greater than or equal to the greatest of all the given numbers. So SCF will always be less than or equal to the smallest of all the given numbers, and LCM will be greater than or equal to the greatest of all the given numbers. Now from the SCF and LCM there is a formula to find out the product or the SCF or LCM if two numbers are given. So the formula states that for any two positive integers a and b, so it is valid for only two positive integers. So for any two positive integers a and b, SCF of a and b times LCM of a and b will be equal to the product of the a and b. So for any two given numbers, the multiplication of their SCF and LCM is equal to the product of the two given numbers. Now let us move ahead to the exercise 1.2. So these were the concepts related to the exercise 1.2, related to the questions of exercise 1.2 from the NCERT book. Now let us try the questions from the exercise 1.2 and check whether we have understood the concepts or not. I'm not going to solve each and every question of this exercise. We will be solving, like if there are many parts, we will be solving one or two parts, and rest you will try by yourself. So let us move to the first question, 140. So first is express each number as a product of its primes. So we have to express each number as a product of its primes. So I think we have done first and second part. Let us check 140 and 156 we already did above. So 146 was 2 square times 7 into 5, and 156 was 2 square times 13 into 3. So first two parts we already did above. Now let us try the third part of the question number 1. So question number 1 and part 3. So it is 3 at 8 to 5. So we have to prime factorize it. Now as we discussed above, the units digit is 5, so it will be divisible by 5. So 5 7 is 35, 3 32, 5 6 is 30, 2 25, 5 5 is 25. Again units digit is 5, so we can divide it by 5. So 5 1 is 5, 2 26, 5 5 is 25, 1 15, 5 3 is 15. Now 3 plus 5 8, 8 plus 1 9. So 9 comes in the table of 3, so we can divide it by 3. So 3 5 is 15 and 3 1 is 3, 51. Again 5 and 1 6. So it comes in the table of 3. It will be divisible by 3. So 17, and 17 is a prime number. So we can divide it by 17, and we got 1. So in this way we can prime factorize any given number. So we can write 3 8 2 5 as 5 comes 2 times. So 5 is square. 3 came 2 times. So 3 square, and 17 came 1 time. So 17. So this is the prime factorization of 3 8 2 5. So we did the three parts of the question number 1. 2 and 3. Remaining 2 you can try by yourself. To increase your speed, we should be aware about the divisibility rules of the numbers. If we know the divisibility rules of any given number, so we can find out whether a given number is divisible by that number or not. So moving to the question number 2, find the LCM and SCF of the following pairs of integers and verify that LCM times SCF is equal to product of the two given numbers or not. So let us try question number 2, part 2, 510 and 92. 510 and 92. So let us try question number 2, part 2. So the two given numbers were, let us take them as x as 510 and y as 92. So let us prime factorize 510. So we can see this is an even number, we can divide it by 2. So 2 to the 4, 1, 11, 2 5 is 10, 1, 10, 2 5 is 10. Evenest digit is 5, we can divide it by 5. So 5 5 is 25, 5 1 is 5. Now again 5 plus 1, 6, 6 is divisible by 3. So we can divide it by 3, 17 times, and 17 is a prime number, so 1. So prime factorization of 510 is 2 into 5 into 3 into 17. And 92 is a smaller number, so we can solve it. So 92 can be written as 2 into 46, and 46 is even, so it will be again divisible by 2, so it will become 2 square times 23. 23 is a prime number, so we cannot factorize it more. So 510, we can write it as 2 times 3 times 5 times 17. I wrote the numbers in increasing order. As we know, prime factorization, by fundamental theorem of arithmetic, that prime factorization of any number is unique apart from the order in which the numbers occur, and y, that is 92, can be written as 2 square times 23. Now we have to find out the LCM. Let us first find out SCF. So SCF is the product of the smallest power of the common factor. So common factor is only 2, which is coming in both, and we have to take the smallest power, so SCF will be 2. SCF is 2. And what is LCM? LCM, we can see, LCM is the product of the greatest power of all the numbers, which all the prime numbers which occurs in any one of the number or in any of the numbers. So if we take the greatest power of 2 is 2 square, then 3, then 5, then 17, and then 23. So we got the SCF and the LCM. SCF of the given numbers is 2 and LCM is 2 square times 3 times 5 times 17 times 23. Now we have to verify the product of LCM and SCF should be equal to the product of the given numbers. So if we find out LCM times SCF, so if I multiply it, so power of 2 will become 3, then 3, then 5, then 17, then 23. And if we multiply the numbers, that is x times y, so 2 square times 2, that is 2 cube, then 3, then 5, then 17, then 23. So from equation 1 and 2, we can say that if we see both is the same thing, 2 cube, 3 into 5 into 17 into 23. So from 1 and 2, we can say LCM of x comma y times SCF of x comma y is equal to x times y. So LCM into SCF of two numbers is equal to the product of the given numbers. So in this way, we solved the second part of the question number 2. Similarly, 26 and 91 are smaller numbers, and 336 and 54 you can try by yourself. Now moving to the question number 3, find the LCM and SCF of the following integers by applying the prime factorization method. So in this case, we have three numbers and we have to find out their LCM and SCF. Remember, we cannot verify this formula LCM into SCF is equal to product of the two numbers, because this formula is valid only for two numbers. So we will try the part 1 of the question number 3. So let us try part 1 of the question number 3. So question number 3, part 1, we have to find out the LCM and SCF of 12, 15 and 21. So 12 we know it is 3 times 4. So 4 can be written as 2 square times 3. 15 is 3 times 5 and 21 is 3 times 7. So now let us try to find out SCF, and we know SCF is the product of the smallest power of the common prime numbers which are present in all the numbers. So only 3 is present in all the prime number and it has the same power 1. So SCF will be 3. And for LCM, it is a product of the greatest power of all the prime numbers. So 2 square times 3 times 5 times 7. So this will be the LCM, and that is 4 times 3 12, 12 times 5 60, 60 times 7 is 420. So SCF of 12, 15 and 21 is 3, means 3 is the greatest number which divides all the 12, 15 and 21. And LCM is the smallest number. Like I cannot find out any number which is smaller than 420 and which comes in the table of all the numbers 12, 15 and 21. So in this way we can think about the SCF and the LCM. So I hope this should be clear to you. Now this was the question number 3, part 1. Now let us move to the question number 4. So 4 is also based on the concept of SCF and LCM, but here we will use the formula LCM times SCF is equal to product of the given numbers and find out one thing which is missing from the given things. So question number 3 we did. Now question number 4. So SCF of 306 and 657 is given 9, and we have to find out LCM. LCM we have to find out. So we know the formula, that is LCM into SCF is equal to product of given two numbers. Product of the given two numbers. Or we can use the division Euclid division algorithm method to find out the SCF. So we will divide 657 by 306. So it will go 2 times. We can see it will be 612. 7 minus 2, 5. 5 minus 1, 4. Now we can divide 306 by 45. So it will go 6 times. So it will be 270. So it will be 6, and 10 minus 7 is 3, 36. Then again we can divide 45 by 36. So 36, 9 is the remainder here. And now we will divide again 36 by 9. So it will go 4 times. So 36, now 0. So what is the SCF? As we saw in the exercise 1.1, the divisor at the step when the remainder becomes 0 is the SCF. So 9 is the SCF of 306 and 657. So we can use now this, we can put the values in this formula. LCM times SCF is equal to product of the given two numbers. So LCM is, we have to find out. LCM we have to find out. So LCM times SCF, that is 9 we got, is equal to product of the given numbers, that is 306 times 657. So from here we can say LCM will be equal to 306 times 657 divided by 9. So if we divide it by 9, 9 7 is 63, 2 27, 9 3 is 27. So it went 73 times. So LCM will be equal to 306 times 73. So which we can multiply. 306 times 73 is 22,338. So the LCM of the two given numbers 306 and 657 is 22,338. In this question, we applied the concept LCM into SCF is equal to product of the two given numbers, and we found out the SCF of the two given numbers by using the Euclid's division algorithm. Now let us see one more application of the fundamental theorem of arithmetic. This is about understanding the properties of the given numbers. So we will move to the question number 5, and 5 asks, check whether 6 to the power n can end with the digit 0 for any natural number n or not. So we have to find out that for any value of n, for any natural number n, can 6 to the power n end with the digit 0 or not. So moving to the question number 5. So 6 to the power n is given. So to understand the properties, let us break it down into its prime factor. So 6 is 2 into 3 times n. So that will be equal to 2 times n, 2 to the power n times 3 to the power n. Now we have to check whether 6 to the power n can end with the digit 0 or not. Means can the units place of 6 to the power n for any natural number n be 0 or not. So if units place of any given number is 0, then that number should be divisible by 5. And 5 is a prime number. So any number will be divisible by 5 only if its prime factorization contains at least one 5. But we can see that in the prime factorization of 6 to the power n, we have only 2 and 3. So we can say that as prime factorization of 6 to the power n does not contain 5. So it cannot end with 0. It cannot have units place 0 for any natural number n. So this was a simple application of the fundamental theorem of arithmetic, and without doing anything, we figured out that 6 to the power n for any natural number n cannot have its unit digit 0. Now let us move to the question number 6. So question number 6 is, explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite numbers. So we discussed as above that what are composite numbers? Any composite number is a number which has more than 2 factors. And we know every positive integer has 2 factors, 1 and the number itself. So to show that these numbers are composite, if I can find out a factor of this number other than 1 and this number, we can surely say that this is a composite number. So we will apply the same concept and we will try to find out a factor of this number other than 1 and the number itself. So let us try to solve it. Question number 6. So 7 into 11 into 13 plus 13. So we have to show that this is a composite number. Now we can see that 13 is present at these both places. So we can take 13 common. So 7 into 11 plus 1. So whatever it is, so if I want to simplify it, so I can write it 13 times 7 into 11 is 77 plus 1 78. So we got 2 factors 13 and 78 of the given number 7 into 11 into 13 plus 13. So we can surely say that 7 into 11 into 13 plus 13 is a composite number, as it has more than 2 factors. Now, question number 7. Let us go through the question number 7. The next part of this question, you can try by yourself. Question number 7 is, there is a circular path around a sports field. Sonia takes 18 minutes to drive one round of the field, while Ravi takes 12 minutes for the same. Suppose they both start at the same point and at the same time and go in the same direction. After how many minutes will they meet again at the starting point? After how many minutes will they meet again at the starting point? So the important thing is they have to meet at the starting point only. It means Sonia will complete every round at 18 minutes and Ravi will complete every round at 12 minutes only. So whatever time we give, at that time Sonia should also complete its round and Ravi should also complete its round. It means that time should be a multiple of 18 and 12. That time should be a multiple of 18 and 12. And we have to find out the common multiples of 18 and 12. So after how many minutes will they meet again at the starting point? Means if I have to find out after how many minutes they meet first time at the starting point, and that will be the LCM of 18 and 12. So let us try to solve it. Question number 7. So let 18 and 12. So these are smaller numbers. We can directly prime factorize it. 18 is 9 into 2 and 9 is 3 square. So we can write it 2 into 3 square. And 12 is 4 into 3. So we can write it 2 square into 3. So we have to find out LCM. And what is LCM? LCM is the product of all the prime numbers with their greatest powers. So these are the numbers which are common in both. And if I have to take their greatest power, so it will be 2 square times 3 square. So 4 into 9, that is 36 minutes. So they will again be meeting at the starting point for the first time at 36 minutes. At 36 minutes, we can check also. Sonia would have completed 2 rounds, and Ravi would have completed 3 rounds, and they will meet at the starting point for the first time. And if we have to check when they will meet again at the starting point, so it will be a multiple of 36. So they will again meet at the starting point at 72 minutes, then 108 minutes. So in this way, at all the multiples of 36, they will be again meeting at the starting point. So these were the questions from exercise 1.2. I hope you would have understood the concepts. Whatever parts we didn't solve, just go through them. It would be easy and we will be able to solve it. In the next lecture, we will be discussing the concepts related to exercise 1.3 and the questions from the exercise 1.3 of the NCERT book. Till then, practice and practice, because practice makes a student perfect.